Okay, so this is section 7.11 of vectors, the final part now of vectors. So here we have a few definitions that are really important. Okay, so in this example 37, we'll look at that in a second. We'll just look at these definitions down here. So the scalar product of two vectors A and B is written as A dot B, sometimes called the dot product for that reason. A dot B. So we write it as just A dot B. Okay, it's called the scalar product. And basically a scalar, remember, a scalar quantity is just a number. It's not a vector, it's just a number. So when we find the dot product here, we're finding a number. Okay. Similarly, the scalar product is also used with angles between vectors. Okay, so for example here, you've got this formula A dot B. The dot product of A and B is equal to the mod of A times the modulus of B, or its magnitude, times the cosine of the angle between them. Okay, now obviously this can be extended to A dot B over the mod of A times the mod of B is equal to the cosine of theta. Okay, and we know that if two vectors, if two vectors are perpendicular to each other, then the angle between them is equal to 90 degrees. And you know that the cos of 90 is equal to 0. So therefore, for two perpendicular vectors, the dot product will be equal to 0. Okay? If two vectors are parallel, well, basically, the angle between them is obviously going to be 0. Okay, and we also know that the cos of 0 is 1. So therefore, the dot product here will be equal to the mod of A times the mod of B, because it's just cosine of theta is just equal to 1. Okay, there are various other things here. So the dot product of A and A is just the modulus squared. And I think that's basically it. The only other important thing to note is in this diagram here, where you have position vectors. You've got 0 here, and you've got the position vector OA and the position vector OB. Now, the important thing here is that to get the angle between them, these two vectors have to go outwards, not one outwards and one inwards. As in example 37, look. Here, you've got, here, this is the diagram that you would have been given this one. So if you look at this one, I'm just going to pause this so I can clear the screen a bit. So for example here, this is this diagram here. You've got the vector A, which is going away from X, but the vector B is not. It's coming towards X. So basically the vector, if this angle is 20, this vector B is going outwards like this. And now, because we have A and B both going away from this point here, this is the angle that we can find, okay? And obviously that is going to be 160, okay? So that's quite important, okay, that you bear that in mind. But the rest is just really, really straightforward. Okay, so we'll move on to the next example now.